So in the previous chapter, we talked about electric forces. We said that charges exist, and the only way we know that they exist is from the fact that they interact by a force. We said that we have two kinds of charges. We have positive charges and negative charges. And positive charges, like charges, would repel each other, and opposite charges will attract. And the magnitude of the force between these charges is given by Coulomb's law. In this presentation, we want to introduce the electric field in a similar way. We want to look at this new concept that we're going to call the electric field, and we're going to see how does it interact with charges if we put them in the electric field. نحن بنعرف شو هو الفيلد، شو معنات كلمة فيلد. في عنا مثلا gravitational field, magnetic field, electric field. نسمع مثلا gravitational field of the earth. نعرف انه لما يكون عنا mass بنحطه بالgravitational field of the earth, it would feel a force اللي هي the weight of the object, which is an attractive force على طول بتكون toward the center of the earth. نعرف مثلا نسمع انه the earth has a magnetic field around it that protect us from radiation and stuff. So we know the concept of field. So we want now to focus on the uniform electric field. So that's the focus of this presentation. So let's imagine that we have a device معمولة من box, معمولة من two plates, two metallic plates. Between them there is empty space. يعني empty space في يكون هواء بس ideally بيكون vacuum. So these metallic plates are on the side, and this device has an on-off button. When I press on this device, what happens is that there's going to be a accumulation of positive charge on one plate and accumulation of negative charge on the other plate. So هيدي مكنة بشكها بالكهرباء أنا وبكبس on عليها. شو بيصير؟ When the positive charge accumulate on one side and the negative charge accumulate on the other side, it means that this device is generating an electric field in this empty space between the plates. So now I know that there is an electric field here, and this electric field is a uniform electric field. شو معناتها؟ معناتها if I take any point O, observation point O, في vector E, هالvector direction تبعه away from the positive plate toward the negative plate, and it has a strength. بعدني أنا مش عارف شو الstrength تبعه بس it's applied at point O and it's directed from the positive plate toward the negative plate, and this is the electric field. And it's uniform, which means that if I take any other point, O prime or P or any other point inside the field again, there is going to be also a field line or a vector E that is applied at this new point O, has the same magnitude as the other one and pointing from the positive to the negative. So it means that I have a uniform electric field inside this device. كتير حلو، بس شو معناتها؟ What does it mean that there is an electric field? أنا عم بقلكم في vector, imaginary vector على point O, point E. There is nothing physical about it, right? Well, there is. Again, people are waiting in the lobby. Okay, so how can I tell how this interacting? I take my device, then I take three charges, one or three objects. One is negatively charged, A carries a negative charge, B is neutral, it has no net charge on it, and C is positive. I attach them from a light string, بعلقهم بحبل رفيع وبحط لهم stand فوق منهم. So I have my stand here on top. Not laser, I don't like the laser. Okay. I have the stand on top, and now what I do is I take this charges and I put them inside my field. I move them inside the field. Then I turn this device on and I observe what happened to these charges when I turn the device on. قلنا when we turn it on, there's an electric field be generated. هلا أول شيء let's look at B. B is neutral. So B ما عنده excess charge, so it should not interact with the field. So QB is 0. البي بتضلها معلقة جالسة ما لا بتزيح لا يمين ولا شمال لا طلوع ولا نزول. So it stays in its position. So there is no force on B. This is logical. بس بعدني I didn't prove the existence of the field. So I look at A. A is a negatively charged particle, right? بس أنا على الشمال حاطط positive plate. والpositive charge attract a negative charge. وعلى اليمين حاطط negative charge. والnegative charge repel a negative charge. So A is going to experience a net force opposite to the field. الفيلد قلنا من البوزيتيف للنيجاتيف. هيدي الفورس على A رح تكون من away from the negative plate toward the positive plate. So it experiences a net force that is directly opposite in direction to the field. يعني صرت أعرف في شيء بهال يعني كيف واحد مثلا بيفوت على بيت بيقولوا فيه أشباح أو شيء بحس بشيء عم بيشده. So now I have a physical proof إنه في شيء عم بيشدني. في force عم بتشدني. الA زاحت. other forces على A إذا بدنا نتذكر في الويت بيكون vertical down وفي tension. So eventually it would reach equilibrium and it would make an angle theta with the vertical. Okay, so A moved under the effect of this electric field. So now I have a proof that this electric field exists. Now C is positively charged, so it's gonna be attracted by the negative side, repelled from the positive side, so it would feel a force to the right. So the net force on C is in the same direction as the electric field. We have a tiny mistake here. This is QC, right? So QC is the one that is larger than 0. So when I put a positive charge in the electric field, it would feel a force in the same direction as the electric field. A negative charge would feel a force opposite to the electric field, and a neutral object would has no force on it. So the way I define the electric field, I define it in terms of the force it exerts on charged particles that are placed inside it. So now I have a physical proof that this electric field is a physical thing. It exists because it interacts with charged particles. And the way I would define it is in terms of this interaction, because forces are something familiar to me. I can measure them. يعني أنا from the angle هون, if I measure the angle وبعرف الماس تبع ال A, I can calculate the force exerted on A اللي عم تشده لليمين أو الشمال. نفس الشيء بالسي. So I can measure these forces. So from the force, I can define the electric field. So how can I do that? So what I'm going to do is I will take my device, still بعدها نفس magical device, magical box that is creating the electric field for me. I turned it on. It has a electric field pointing من الشمال لليمين. هلا طبعا في لبا في طلع نزول هو من الشمال لليمين جوات الديفايس. في حركة أنا مثل ما بدي. So I can rearrange this thing as the way I want. And now what I do is I take a tiny point charge, I call it a test charge Q, and I place it inside the field. And I say that the force that this charge is going to experience should depend, logically, it should depend on two things. ليه؟ لأن هي الانتراكشن بين التشارج وبين الفيلد. يعني لازم تعتمد على الماجنتيود والساين للتشارج، ولازم تعتمد على السترينث يعني قد ايه قوة الفيلد and its direction. So it should depend on the magnitude and the sign of Q and on the strength and the direction of E. So I define the electric field by the force it exerts on a test charge inside it. And the definition that I'm going to use, F, the force on the charge, is equal to Q times E. So I am introducing this as a definition of the electric field. So if I know that there is an electric field, the electric field vector, how can I measure it in the lab, or how can I say that there is something that exists here? I put a test charge there. I measure the force. There are different ways to measure forces. يا اما يكون في عندي force sensor، يا اما بشوف قد ايه بيعمل deviation by the angle and I apply Newton's law. So I know from classical mechanics how can I measure a force. Then I say that the electric field at that location of this charge is related to the force. The force is a vector, والelectric field is a vector, and to Q by this equation, or I can of course flip it and say that E vector is equal to F over Q. Let's see if this definition apply to what I did in the previous section. انه الفورس على البوزيتيف تشارج بتكون in the same direction as the field, والنيجاتيف تشارج بتكون opposite direction to the field. باخد اول شيء الكيس الكيو بوزيتيف، باخد هالتست تشارج تكون بوزيتيف. إذا الكيو positive, this equation means that F and E are in the same direction, and that's what I want. So this actually fit my need. انه لما يكونوا الكيو positive, الفورس on it بدها تكون in the same direction as the electric field. Second, I take a case where I have negative charge. طيب إذا عندي ال F equal to minus E vector wise، بس قول الفورس ضربتها بماينس ساين، يعني بعكس لها الاتجاه تبعها، يعني الفورس بتكون عكس ال E، and that what I also want. يعني ال negative charge is attracted toward the positive plate, while positive charge is attracted toward the negative plate. هلا magnitude، أنا ما كنت معرف الماgnitude تبع الإلكتريك field, so I can say that the magnitude of the force depend on Q, which makes sense, and it should depend on the strength of the electric field. So ال F بتساوي absolute value of Q times E. هلا ما حطيت arrow على ال F وما حطيت arrow على ال E, so this is a magnitude equation now. So ال magnitude ال F بيساوي قد ايه كبير التشارج، كل ما كبر التشارج I would expect the force on it to be bigger. وكل ما كبر هيدي الديفايس تبعيتي، اذا حطيتها بكهرباء 110 او حطيتها بكهرباء 120 او حطيتها عنا بلبنان ما بتشتغل بالمره، it would make a bigger electric field. The bigger the electric field is, the bigger the forces. So now I can define the electric field, and I say that the strength, the field strengths depend on شو؟ It has to depend on the source. أنا من وين جايبها؟ So بتعتمد أنا هول البليتس تبعولي قد ايه كبار، بتعتمد قد ايه مقربهم لبعضهم، بتعتمد قد ايه بعاد عن بعضهم. بس how do I measure it? I measure it as when I put the test charge, I measure the force F, and then I take the electric field equal to F over Q. بس مش معناتها الإلكتريك فيلد تعتمد على Q. هاي الكيو هي تست تشارج، هاي الإلكتريك فيلد هي وين السورس تبعها؟ هاي الديفايس اللي أنا بلشت فيها بأول الشابتر. أنا قلت أنا I build a device that generate an electric field. هاي الديفايس عندها properties قلنا معمولة من plates. هالبليتس فيهم يكونوا كبار، فيهم يكونوا صغار، فيهم يكونوا قراب لبعضهم، فيهم يكونوا بعيد عن بعضهم، في يدورها على بطارية 12 فولت، في يدورها على بطارية 24 فولت. So this is an electric device. So the electric field strength should depend on the device itself. But I can measure it in the lab, or I can measure it in an experiment by taking a small charge. في أخذ atom أو molecule oxygen ion, I put it in there and I see how it moves. في يقيس قد ايه بدها وقت لتروح من الأول للآخر. Then I find the acceleration, then I find the force, and then I can find the electric field as F over Q. طيب, let's take an example. So F, force due to the electric field. So let's take this ion. So we take an O2 minus ion. So it's an oxygen ion. It has 2 extra electrons. So its charge is minus 2e, and I place it inside the electric field. And the acceleration, I was able to measure how much its acceleration is. It turns out to be 20,000 meter per second squared to the left. So this particle is accelerating to the left with a acceleration of 20,000 meter per second squared. Part A, what is the forces exerted on the ion? Part B, what is the direction of the electric field? What is the strength of the electric field? طيب regarding the أول شيء قبل ما نبلش بدنا الماس والتشارج للبارتيكل. So الماس of oxygen is 16 AMU. ال AMU هي الماس 1 AMU or atomic mass unit هي الماس of one proton أو تقريبا mass of one proton, which we have it in our table. So we substitute that in kilograms, so it is 2.66 times 10 to the negative 26 kilogram. والcharge هو minus 2e لأنه هي ربحاني 2 electrons extra. So والe هي 1.6 times 10 to the negative 19. So that's minus 3.2 times 10 to the negative 19 coulomb. هلا what are the forces exerted on the ion? لأنه we're talking about an ion, a very very small mass, so we can ignore all gravitational interactions. يعني إذا I calculate the weight رح يطلع أصغر من electric force ب millions and billions of times. So it's useless to calculate. كيف مثلا سيارة ماشي مثلا داعسة بنزين وأنا مثلا عم بنفخ عليها لخفف لها سرعتها. It's not gonna make any difference. So I don't need to calculate it. So I assume that the only force on this particle is the electric force. So it's the force exerted by the ion. So the weight of the ion is negligible, and the only force acting on it is due to the electric field. So we have a force. هلا ما بعرف الدايركشن بعدني تبعها، لأن حتى الإلكتريك فيلد ما بعرف الدايركشن لإله. بس أنا شو بعرف؟ بعرف إنه نيوتنز لو بيقول لي إنه ال F equal to ma، بس هيدي the only force. والmass is always positive. M is always larger than 0. There is no other option for M. So M is larger than 0. Then the force and acceleration are gonna always be in the same direction. Net force and the acceleration are always in the same direction. بس لما تكون هيدي الفورس هي الوحيدة، so هي net force, so F has to be to the left. So I know the direction of the force. So أنا بعرف إنه the force is to the left. طيب what is the direction of the electric field هلا؟ بيجي بتذكر أنا شو العلاقة بين الفورس وال electric field. بس قبل ما نجيب direction of the electric field خلينا نجيب الماgnitude لهالفورس. So the magnitude of F هيدي Newton's law. I take an axis here. I can project it on the x-axis. So باخد x-axis هيك. I can project on the x-axis. Or I can directly work with magnitude لأنه عندي one force و one acceleration. So I can say that the magnitude of F is equal to the absolute value of ma. So I don't really care about the direction. So الماس معي ومعي الاكسلريشن, so I can find the force. So this is still a very small force, right? It's 10 to the negative 22. But it is significantly larger than what the weight of the ion would be. ليه؟ لأنه الأيون إذا بياخد الويت تبعه هو mass times gravity. So it's 2.66 times 10 power minus 26 times 10. So it would be in the order of 10 to the negative 25. يعني هيدي أكبر ب1000 مرة من الويت. So الإي شو الريليشن بين الإي والأف؟ الفورس بتيجي من الإي. So الإي is equal to F over Q. That's the definition of the electric force. So هي نحن نكتبها F, or easier to remember إنه الفورس is equal to Q E, or E equal to F over Q. هل شو بنتذكر شغلتين؟ إذا ال Q positive ال F وال E are in the same direction. إذا ال Q negative ال F وال E عكس بعضهم. بس هون ال Q شو؟ negative. So it is a negative ion, so Q is negative. Q is negative means F and E are opposite. والF نحن وين لأيها ميل لقيناها؟ لقيناها to the left. So الE لأيها ميل بدها تكون it's to the right. هلا الماجنتيود تبعها كمان I take the absolute value, I do a magnitude equation لأنه كمان عندي one vector. I can do that easily without projections. So I have 10 power minus 22 over 10 power minus 19. So that's 1.7 times 10 power minus 3. هلا the thing that we forgot to mention in the previous slide هو الunit تبع the strength of the electric field. The force I measure it in Newton. The charge I measure it in Coulomb. So the electric field I should measure it in what? In Newton per Coulomb. لأنه هي force over charge. So I measure it in Newton over Coulomb. The other thing I know إنه لأنه الإلكتريك فيلد is directed to the right, so بعرف إنه البليت عملت اللي الشمال بده يكون positive والبليت عملت اليمين بده يكون negative. هلا ما سألونا عنه هون بس we kind of can add that piece of information and that makes sense إنه هالنيجاتيف charge اللي بالنص بده تكون attracted toward the positive plate and repelled by the negative plate. يعني الفورس تبعها بدها تكون to the left. طيب next so let's recap what we have. عطول in any case if I'm looking at an object I always can use Newton's law. F net equal to ma والmass is always a positive number, it's a positive scalar. So F net والA are always in the same direction. بس Newton's law بيقول لي عن النت فورس اللي هي sum of all forces. بالبروبلم اللي قبله كان عندنا special case, كان عندنا net force هي الفورس. So it was easy for me. ما كان عندي multiple forces on the object. So I knew that the electric force was equal or in the same direction as the acceleration. بس إذا كان في عندي غير forces I have to pay attention. The other thing, one of the forces that can be exerted on the object إذا هالobject عنده charge وحطيته بإلكتريك فيلد أنا it would feel a force وهيدي الفورس بدها تكون equal to QE. so هيدي التشارج هي للobject وهيدي الE هي مطرح ما أنا حطيته يعني بأي وين حطيته. so it is location dependent. والQ هي intrinsic property of the object itself. والQ فيها تكون positive و negative. إذا الQ positive الF والE بيكونوا same direction. إذا الQ negative الF والE would be opposite. So here I have to emphasize on this point. F is a vector. E is a vector. So يعني أنا بقولكم بهيدي النقطة بالعالم في electric field. شو يعني؟ يعني في عندي kind of a vector is applied at that point, has a direction and it has a magnitude. هلا it depend what does depend on where it comes from. الحديث هلا بعد ما اشتغلنا بهالموضوع. That's gonna be the story of our next lecture. But as far as we know, we have an electric field. How can we tell that we have an electric field? إذا جبنا charge حطيناه على هاي النقطة and then this charge is gonna feel a force and هاي الفورس I know how to measure it. So let's go back to this ball A. let's نفترض ان احنا ال A كانت negatively charged. let's نفترض انه ال A كانت عندها charge minus 2 milli coulomb, milli 10 to the negative 3 والماس تبعها 20 جرام. زاحت هي بس حطيتها انا بالالكتريك فيلد ودورت الالكتريك فيلد. when I turned on the electric field it moved right. let's هون لازم نكون مدورين الالكتريك فيلد. okay so when the electric field was on the charge moved, it moved to the left. صارت عاملة انجل مع الفيرتيكال. هاي الانجل اللي عملتها مع الفيرتيكال هون هي نفس الانجل اللي هون. هلا هون this object has a large mass, it has a mass of 20 gram, so I cannot ignore the weight. So I have to consider all the forces exerted on this object. So what are the forces exerting on this object? First, I have weight. Weight is always vertical down. Good. Then we have second, we have tension in the wire. هي الطابة محمولة بحبل. الحبل هو اللي مهدية. لو ما في حبل كانت بدها توقع وتروح على الشمال أكتر. So الحبل has a tension. Tension على طول is along the wire. So this is T. Okay. So then this has a charge and it's placed in an electric field. So there is an electric force on it. لأن التشارج تبعها نيجاتيف الفورس عليها بدها تكون عكس الالكتريك فيلد. So بدها تكون to the left. So this is the force F on it. It's directed opposite to the electric field. طيب. And I want to find this electric field. So I want to find the magnitude and the direction of the electric field. أول شيء direction I kind of assume it. I assume the direction is in this way. هاي الالكتريك فيلد. كرمال هيك الفورس طلعت to the left. بس أنا I could deduce it logically. لأنه الكيو نيجاتيف الأف والأف هي للشمال. إجباري تكون للشمال لأنه البندنج لليمين مش معقول أنا أكون سوري للشمال مش معقول أكون أنا عم شد فيها على اليمين وهي رايحة على الشمال لأنه الويت vertical down والتنشن بيلحق شو بيصير يعني إذا ما في فورس عليها بتنزل vertical يعني التنشن بيكون vertical. So أنا بس شدها على الشمال بتزيح على الشمال. So الأف is to the left يعني ال E is gonna be to the right. So that's first I deduce the direction of E. Now to find the magnitude of E I have to find the magnitude of F. So I apply Newton's law. طيب هاي البارتيكل زاحت ووقفت ما طلعت عم تروح وتجي. So الاكسلريشن تبعها قد ايه؟ زيرو. شو يعني؟ يعني sum of forces الأف net on it is zero. So I can add all the forces F vector plus W vector plus T vector اللي هي equal to MA. That's general Newton's law. In this case is equal to zero. هلا هون we have to be careful. قبل بالبروبلم اللي قبله لأنه كان عندي فورس وحدة كان I was able to move directly to magnitudes. بس هون لأنه عندي أكثر من فورس وكل وحدة عندها direction شكل I have to do projections. So I have to choose my axes and to do projections. ما بعرف ليه حاطط ال T أنا هون زيحة معي. So هيدي الفاكتور دي. So I choose the x-axis horizontal. هختاره على الشمال لميلة الأف حتى ما يطلع عندي الأف نيجاتيف بس مش معناتها إنه بيتغير شيء بالبروبلم. الchoice of the axes I can choose it whatever I want. أنا معود على طول أخذ ال x-axis على اليمين. I could بس ما رح تأثر. So just to show you إنه ما بتفرق شيء. والy axis خليته مثل ما معودين vertical up. I could have taken it vertical down. So I project this equation اللي هي الvector equation على x axis بالأول. F is along the x axis and it's along the positive x axis. So I got plus F. The weight has no component on the x axis. So it's zero. Tension هلا. If we look at the tension, let's draw it here. So this is the y axis. This is the x axis and this is the tension. The angle that the tension makes with the y-axis, this angle here, is the same as the angle that the wire makes with the vertical. لأنه y-axis أنا مختاره vertical والtension is along the wire. So this is 20 degrees. So it makes an angle 20 مش مع x-axis مع y-axis. So when I project on the x, I'm projecting on the opposite of the angle. هيدي x component. خلينا نرسمها بجرين. هي الx component. It's opposite to the 20 degree. So I have to use sine. And also it's going in the negative x-axis لأنه هيدا الpositive x-axis. So هي رايحة بالnegative x-axis لورا راجعة. So it is minus t sine 20. So I got my first relation. I got F is equal to t sine 20. بس أنا t ما بعرفها لأجيب الF. So I have to project on the y-axis to find t. So على y-axis خلينا نرجع على الأحمر. عندي F ما عندي. So I have 0 from F. Then I have the mg is pointing down, so it's minus mg. Then the tension and the هيدي component, let's draw it here. So this is the y component, أو هيدا هون هو the y component. It's adjacent to the angle. So I have cosine, and it's upward in the same direction as the y-axis, so it's plus cosine t cosine 20. And then I find t is equal to mg cosine 20. I take it back and substitute it here. So I find f equal to mg sine 20 over cosine 20. So هيدي equal to mg tangent 20. ليه؟ لأنه sine over cosine is tangent. بس أنا شو بعرف إنه الf بتساوي absolute value of q times e. الماس ما بدي أحط لها absolute value، على طول positive. بس التشارج لما كنت صرت عم بحكي عن magnitude بدي أحط لها absolute value، لأنه التشارج فيكون positive فيكون negative. So I have FQE, then I can find E equal to mg tangent 20 بقسم على q both sides divide by q. هلا this is the magnitude of E and the direction is to the right, and I need to know about the electric field. هلا this is a uniform electric field، يعني على A في electric field in that direction، على أي line point تاني بخدها هون كمان في electric field in that direction. فأنا to represent the electric field شو بعمل؟ برسم arrow طويل هيك على الزاوية بس to indicate إنه بهاي الريجن اللي مصوره أنا بأبيض هون في electric field in that direction. هلا sometimes I draw more than one arrow. We're gonna talk about that later. هذا بنسميهم field lines. We're gonna discuss them in later presentations. Regarding the units, الماس بدي حوله للكيلوغرام. So الماس عندي إياه بالجرام. 20 gram. So I need to change that to kilogram, so that I multiply by 10 power minus 3. So that's 20 times 10 power minus 3 a kilogram. والتشارج كمان بدي حوله اعطيني اياه بالملي كولوم، بدي حوله للكولوم كمان من ملي لكولوم، من ملي كولوم لكولوم كمان 10 باور minus 3. So بتصير 2 times 10 power minus 3. والجي is a constant. I can use it 9.8 كيلوغرام نيوتن بير كيلوغرام او متر بير سكند سكويرد. وتنجن ثيتا is unitless. بس بدي انتبه انه الكالكوليتر تبعيتي تكون يا بالديجري يا بالراديانت. So in this case it is in degree. Okay, let's look at these examples. So an electron is initially moving to the right when it enters a uniform electric field directed upward. Which trajectory shown below will the electron follow? الإلكترون كانت ماشي بحال سبيلة to the right, horizontal to the right. فجأة فاتت بمحل في electric field. يعني أنا شو بكون عامل؟ بكون عامل بخش صغير بهاي الديفايس تبعيتي وحطتها sideways، يعني electric field directed upward. فاتت من الجنب هي الإلكترون. then it's gonna deviate, it's gonna feel a force. بأي اتجاه رح تروح؟ رح تطلع تعمل right turn sharp turn وتطلع على العكس، أو it's gonna go to y، أو رح تضل ماشي على horizontal direction w، أو it's gonna bend downward in the z direction. What do you think? So in order to know which direction it's going to bend, I need to know what is the force on it. So when the electron enters the electric field, it's going to feel. So it's going to feel a force. So the force on the electron, لأنه electron is negatively charged, so the force on the electron is going to be negative. It's going to be opposite to the field. So the field is upward. The force كيف بدها تكون؟ بدها تكون downward. So the electron is going to deviate opposite to the field. So it's going to deviate downward. So it's going to go in the z direction. هلا in any case ما معقول تروح in the x direction. ليه؟ لأنه usually particles in nature don't do these sharp turns. لتقدر تروحها بالعكس بدها توقف وترجع تروح. So it doesn't do that. يعني لو كانت بدها bend upward بدها تكون W. وإذا كان الفورس عليها horizontal بتكون بتكون Y. إذا كان الفورس عليها بتكون W. بس there is no way it's gonna be X. But in this case it's just Z because it's bending opposite to the field. So number 2, an electron moving initially with a speed c over 10 enters a region of uniform electric field directed parallel to the electron velocity. So عندي electron كانت ماشي كمان سرعتها c over 10. c is the speed of light اللي هي 3 times 10 power 8 meter per second. So it's a constant number. So ماشي بسرعة منيح الإلكترون. It goes into the field. بهالفيلد الدايركشن تبعه parallel to the electron velocity in the same direction as the electron velocity. يعني the velocity of the electron is in the same direction as the electric field. That's V initial. So does the electron speed up or slow down? هلا it's not gonna deviate. ما رح تطلع لا طلوع ولا نزول. ليه؟ لأنه نفس الدايركشن نفس البارallel. بس كيف الفورس؟ لا أعرف إذا بدي تسرع ولا بدي تخفف. بدي أطلع على الفورس تبعها. So الQ شو هي؟ is an electron. So it is negative Q. So it's gonna feel a force opposite to the electric field. So the force is opposite to the electric field. So it's opposite to the initial velocity. يعني شغلة كانت ماشي على اليمين وأنا عم شدها على الشمال. شو بدها تعمل؟ بدها تخفف. So the force is opposite to the field. يعني الفورس opposite to the velocity. يعني الإلكترون is gonna slow down. طيب, let's actually take this one step further. If we know the strength of the electric field, if we know that the electric field is 200 Newton per Coulomb, how long does the electron move before it stops? يعني بدي أشوف قديش بتمشي مسافة قبل ما توقف. ليه؟ لأنها هي عم تخفف. So eventually it's gonna stop. So بدي أشوف قديش بتمشي مسافة قبل ما توقف أو وقت. So شو بعمل؟ باخد الأكس أكسس لأنه بدي أشتغل بفورس وفيلوسيتي electric field. It's easier for me to take an axis. So I took the x-axis in the direction of the initial velocity. So then the force exerted on the electron is QE. بس هيدي is in the negative x direction. So I know the magnitude of the force is QE يعني EE. هاي magnitude على طول positive. بس direction كيف is in the negative x direction. So now I apply Newton's law. I say Newton's law of the electron بيقول لي إنه F equal to ma. طبعا هاي electron, so I can ignore gravitational forces. That's the only force on the electron. F equal to ma. I projected on the x-axis. I got minus F لأن in the negative x-axis equal to max. ال ax بعدها ax هون بعدها component. So it could be positive or negative. So ax turns out to be negative. So it's equal to minus F over m. So it's equal to minus EE over m. هلا I write the equation of motion. لما يكون particle عندها constant acceleration, then it has an equation of motion. V equal in the x direction is equal to Vx0 or Vx initial plus the acceleration times time. So باخد هاي لتاني ميل بيصير في عندي دلتا في. هلا ال V final أنا بدي إياها to stop. يعني ده بدي أخد ال Vx final. I want to take it equal to 0. So ال Vx final equal to 0. So بيصير في عندي minus Vx0 over the acceleration over minus. So minus sign cancels out and I got the time in positive. I got a positive time. It is proportional to the mass, the initial velocity, inversely proportional to the charge and the electric field. Let's see if that makes sense. So إذا نحن بنفكر فيها, الوقت اللي بتاخده أي شغلة لتوقف, إذا أنا كبيت طابع عليكم بدكم توقفوها. الانرجي او time you take to stop it should be proportional to how fast this ball is moving. لانه كل ما كانت اسرع كل ما انا بدي احط فورس عليها اكبر لوقفها او بدي وقت اطول لوقفها. يعني تخيل مثلا سيارة عم تكرر and I'm pushing it. So it makes sense to be proportional to the initial velocity, the magnitude of the initial velocity. Second, makes sense to be proportional to the mass. ليه؟ لأنه كل ما كان وزنها أكبر كل ما الكيناتيك انرجي تبعها أكبر كل ما كان بدها وقت أكتر كل ما بدها انرجي أكتر لتوقف. So it makes sense it would take more time if it was heavier. Then it makes sense إنه هيدي التايم is inversely proportional to the force I exert on the particle. كل ما أحط الفورس تبعيتي أقوى كل ما فيه يوقفها أسرع. So it would make sense إنه تكون inversely proportional to E. طبعا والفورس بدها تكون proportional للتشارج وللإلكتريك فيلد. So it is F is equal to E. هلا طبعا هاي البارتيكل ما بتوقف وبتضلها واقفة لأنه الفورس ما بتروح. إذا بعدنا بالإلكتريك فيلد بتروح بتقدم توصل لمحل بتوقف وبترجع مثل كأني أنا مسكت طابة وكبيتها بالهواء تطلع طلوع توصل للماكسيموم هايت وبترجع بتبلش تنزل لأنه it's exactly the same. The weight of a massive particle, massive يعني مش massive أي particle عندها mass يعني behaves the same way as this. بس هون الفرق الإلكتريك فيلد أنا فيه أتحكم باتجاهه مثل ما أنا بدي. الجرافيتيشنال فيلد على طول كيف بده يكون vertical downward. طيب So below a thundercloud is a uniform electric field of magnitude of 15 kilo newton per coulomb. هي per coulomb. So شو بيصير بس يصير في عنا thunder cloud؟ الغيمة بسبب الاحتكاك وبسبب الموشن بيصير في انتقال of electrons. So بيصير في electric field بيصير في mainly positive mainly negative بيصير في electric field in the middle. So this electric field actually is a very very high strength. The strength of this electric field is 15 kilonewton. This is between the cloud and the ground. So when this electric field reaches a very high strength, air usually is an insulator. It becomes a conductor. بتحول لconductor and then electrons move from the ground up or from up to the ground. هلا لأنه electrons electric field is pointing downward. So this is the electric field. It's pointing downward. الفورس على الإلكترون كيف بده يكون؟ الفورس on the electron بده يكون opposite to the electric field. So it's going to be upward. So the electrons are going to move upward from the ground to the sky. By energy transfer, it doesn't matter in which direction the electrons are moving. So we have a lot of energy being deliberate. That's why we see a light. Light شو هو بس الالكترونز يضربوا الموليكيولز تبع انا تعبت حتى تبع الاير الاكسجين والنيتروجين بيعملوا لهم اكسايتيشن. بس يعملوا لهم اكسايتيشن بتعرفوا بالكيمستري ما بعرف اذا اخذتون they would relax بيرجعوا بيعطونا هالانرجي بيرجعوا لنا هالانرجي كيف بيعطونا اياها؟ ضوء and of course sound that comes. So we see the light and the sound. So بس نشوف البرق هاي الخط اللي بنشوفه بالسماء هو هيدي الطريقة اللي ماشي عليها الالكترونز. طبعا ما بيمشوا straight up بيمشوا kind of zigzag. لأنه we're gonna learn later بس ناخد the resistance وهيك اشياء انه الالكترونز would follow the path of the lowest resistance. So it depends على humidity, it depends on other stuff, so it looks like zigzag. So find the force on the electron and find the electron's acceleration. كمان هون it's simple. I don't need to take axes here لأنه عندي only one force and one direction. So I know that the force is equal to QE and it's directed upward لأنه بدها تكون عكس ال E. ونيوتنز لو بيقول لي إنه ال F equal to MA. So ال A بدها تكون upward وال A بدها تكون equal to F over M. So it's going to be equal to E over M.